Alright, so let's go and check out this guy right here, where we have a boat that's traveling at 9 kilometers upstream and 9 kilometers back down. And the time for the round trip is 5 hours, and the speed of the stream itself, the water, is at 3 kilometers per hour. So our question is, what is the speed of the boat in still water? Alright, so let's just go through the entire problem here and make some sense of this. So anytime that we're dealing with distance, rate, and time, we always have this relationship. Distance equals rate multiplied by time. So we're going to use that right there in relationship to this. Let's go ahead and plug in what we do know. Well, we do know that our 9 kilometers is going to be our distance, right? So we can go ahead and put that for both going up and down. So I'm going to say we're going to go 9 kilometers going up and 9 kilometers going down, right? Now, and then we'll do the time here last. So it says that the speed of the stream is 3 kilometers per hour. So if we think about this, that means if you think about a stream, right, and if it's going down because water travels down naturally, then that means that downstream it's traveling at 3 kilometers per hour. So when it says the speed of the stream, well, that's obviously down. So check this out. We use that logic to do this guy. When it says, what about the upstream? Well, whatever the rate is, which we don't know, so whatever the rate is, I'm going to subtract 3 kilometers per hour. Right? Because if I'm traveling up, it's going to slow me down at 3 kilometers per hour, however long I'm going to be traveling for. So that's what the minus comes from, just from using kind of logic here, that if we're going up a stream, I'm going against the current. All right, and then same thing if I'm going to start to travel down, well, that means I'm going to get a little boosty. So it's x plus 3 now. So it's my rates. So it's really, I'll just say x equals our rate. What is this? Oh, so that's going to be our rate, our boat in still water. So our rate in still water. All right. And lastly, what about this whole time business right here? Well, we know that the time for the round trip is five hours, right? So we don't know what the first time is or the second time, but we do know that if you add these times together, that's going to give us 5 hours. So check this out. I'm going to call this our time 1 and our time 2 and see if this can make some sense here. If I take my time 1 plus my time 2, doesn't that equal 5 hours, right? That's what it says right here. It says our round trip is 5 hours. So check this out. Let's go ahead and replace T1 and T2. You say, well, how do we know what that is? Well, check this out right here. Remember, time can also be written as distance over rate. I just divide both sides by r right here. So what I'm trying to say right now is that I can replace T1 with distance over rate. Distance over rate. So that means this guy right here can be rewritten as 9 over x minus 3 plus, and then this guy can be written as 9 over x plus 3, and that all equals 5 hours. So my time 1 is 9 over x minus 3, or my distance over my rate, and then my T2 I replaced as 9 over x plus 3 equals 5. So really, all we have to do is just solve for x, because remember, x stands for our rate in still water. So going through this rather quickly now, I want to multiply by our common denominator, our lowest common denominator. And our lowest common denominator here, let me change pens there. Our lowest common denominator is x minus 3 times x plus 3, right? So I'm going to multiply my first term. Well, let's just multiply everything by that then. So I'm going to do x minus 3 times x plus 3, and then I'm going to have my 9 over x minus 3, and then let's multiply everything again by our LCD, and we have our 9 over x plus 3, and that's equal to x minus 3, x plus 3. Multiply that by 5. Cool. Well, we know that all these kind of things cancel out here, which is what we want here, right? So that's nice, and that's why we're left with just then 9 times x plus 3 plus 9 times x minus 3, and left with this guy. I'm going to go ahead and multiply this out right now. So 5 times x squared minus 9. Sweet. So let's just go and start collecting like terms, right? If I multiply these through, 9x plus 27, and multiply those guys through, I get 9x minus 27. And once again, let's go ahead and multiply this through. So 5x squared minus 45. Cool. So plus 27 minus 27 is gone. I can combine my 9x's together and get 18x. And then I'm left with 5x squared minus 45. Let me just go ahead and move this guy over here by subtracting 18x from both sides. Okay, go ahead and do that. So I'm left with 0 equals 5x squared minus 18x minus 45. And if that wasn't as fun as we thought it would be, we can now do the quadratic formula, because this is not factorable. So because that's more brute work, I'm just going to go to Wolfram Alpha, and I kind of already plugged that in right here. So when I plugged it in, we have the answer right here, 9/5 minus 3 radical 34 over 5, and 9 over 5 plus 3 radical 34 over 5. Also known as, we also have our decimal versions of that. So does this give us the decimal version? Kind of. It's like negative, was that 1, 2, 3, 4? It's like negative 1.8 or so, and then this is 5 point something. So I think the answer was supposed to be written in decimal form. So I think we would cross this out, right? Because if we look at our quadratic, the x-intercepts is what we just found. You can't have a negative speed, right? So you just cross that out. So we know that the answer has to be this guy right here, right? So if you just plug that into your calculator, and then you can get your decimal version. I believe it was like 5.3 or something like that.